Good morning and happy Cinco de Mayo. Feliz Cinco de Mayo. All right, today what we're going to be talking about is classifying chemical reactions. In other words, being able to look at a chemical reaction and tell which of the 5 types you need to know they are. So, without further hesitation, let's go through them. The first of these is synthesis. Synthesis is a word that means making something from less complicated parts. And that's what our reaction is. We have any number of reactants, more than one, but we only have one product. That is a synthesis reaction. The example being A plus B gives AB. All right, the opposite of synthesis is decomposition. In decomposition, we have the reverse. We have one reactant becoming more than one product. All right, the third type is called a single replacement reaction. This is where we have one element together with a compound, and because of properties that we'll talk about, they switch places. So here, A is by itself and B is included in a compound. And when all is said and done, A is now in a compound with Y and B is all by itself. So an element plus a compound that switch places. That's a single replacement reaction. You can also have a double replacement reaction. That's where we have two compounds and they also both switch partners. Okay, so here A is with X, A ends up with Y. Here B is with Y, but B ends up with X. That's called a double replacement reaction. All right, the last of the 5 that you need to know are called combustion. Combustion, we think about it as burning. It doesn't always occur with a flame. Sometimes it happens much smaller. For example, cellular respiration is a combustion reaction, but because it is broken down into tiny little steps inside your cells, you are not on fire. All right, so the example here or the model here is any compound, or actually doesn't have to be a compound, could be an element, combining with oxygen, O2, to form some oxide, plus usually some side product. And the side product can be familiar to us. For example, if we burn a hydrocarbon or a carbohydrate, so CHO or CH plus oxygen, we're going to get carbon dioxide and water as products. That probably goes a little bit beyond what we need to know just for the model, but it's an important thing to know. It'll be a very common reaction to see a carbohydrate or a hydrocarbon combining with oxygen to form carbon dioxide and water. Okay. All right. So let's look at examples of actual reactions. In our first example, we have synthesis. In our synthesis reaction, we've got nitrogen combining with hydrogen to form ammonia. One product indicates that this is a synthesis reaction. All right, the next one we have decomposition. In our decomposition reaction, we have one reactant forming multiple products. That's how we know we have decomposition. In this case, this is the decomposition of hydrogen peroxide into water and oxygen. All right, in our third place, we have a single replacement reaction. Here we have copper metal being submerged in a bath of silver nitrate in aqueous solution. And what we end up with is solid silver crystals in a bath of copper 2 nitrate solution. And I'm going to post a couple of videos of some of these reactions because that's a pretty cool one, and I wish we were in class so that we could do it. All right, the next one up, we have double replacement. Okay, in a double replacement reaction, we've got two different compounds. In this case, we have lead 4 nitrate and sodium hydroxide. Lead 4 nitrate, sodium hydroxide, and they are switching places. In this case, the lead is getting together with our hydroxide and our sodium with our nitrate. And what we end up forming is a solid product. In this case, we call it a precipitate. When you have two aqueous solutions and we end up getting a solid product out of that, we call that a precipitate reaction. That is a specific kind of a double replacement reaction, and we'll be getting into that. Okay, so again, they've changed partners. Lead came in with nitrate, and now lead is with hydroxide. Sodium came in with hydroxide and is now with nitrate. So a double replacement reaction. Okay, next up we have combustion. All right, a combustion reaction means that something is combining with oxygen. In this case, we have methane. Methane is a hydrocarbon. Methane combines with oxygen to form carbon dioxide and water. Anytime from here forward that somebody gives you either a hydrocarbon or a carbohydrate and puts it next to oxygen, you can predict that our products are going to be carbon dioxide and water. I think that's fair to hold you to that. It's a simple one. All right, next up, we have this example of hydrogen combining with oxygen to form water. That is, yes, indeed, it's a combustion reaction because it includes the combination with oxygen, but it is also, and rightly so, a synthesis reaction because we have one product and more than one reactant. Okay, be looking for some practice problems, and thank you for listening.